This is part 2 of compound inequalities. So we covered in part 1, students will be able to understand and graph compound inequalities. Part 2, we'll be able to solve and graph compound inequalities. In the previous video, we learned about compound ands and compound ors. And we talked about them specifically when they were written with the word and in or in the case of an and, it can be written 2 different ways. Like we could have like 10 is less than x, which is less than or equal to 40. That's an example of a compound and. You could also have it written as x is greater than 10 and x is less than or equal to 40. So again, that's another way that we could write it. Ors will always have the word or written in between them. So you could have, x is less than 4 or x is greater than or equal to 50. Something like that. So ands can be written 2 different ways. Ors will always have the word or written in there. This is a compound and. Now, you're going to notice that the middle of this looks a little different than we're used to. It's not just a variable. That means we actually have to do a little bit of algebra before we can graph this. So you're going to have to turn this into 2 compound ands split apart. Right now it's kind of written together. So I'm going to take this and I'm going to underline. What you're going to notice here is that I'm underlining the middle twice because you need to write the middle twice. One of the greatest temptations for students on a question like this is to take it and try to split it right in half. And so incorrectly write something like, what the heck? Incorrectly write something like this. Okay, it just doesn't make any sense how that's written. So again, the middle gets written twice. Uh-oh, my pen's getting a little wonky right now. Sometimes it happens. And this is a compound and, so I like to remind myself that it's an and. So again, I took this and split this, rewrote the middle twice. Now, the objective or the idea here is that you're going to solve both of these. Okay, and then we're going to graph what we have, and then it's a compound and. Look at where the solutions overlap. So we're going to move the 6 by subtracting. So you end up with negative 24 is less than x, not 6, is less than x. This is a compound and. I'm going to subtract the 6 here. So you're going to notice that sometimes it's like, oh, I did the same step. Yeah, I mean, because the middle was the same, right, for both of them. And then it's 24 minus 6, so we're going to get 18. Okay, so now we have a compound and. Negative 24 is less than x, and x is less than or equal to 18. Now, I don't like this personally, how this is written, so I'm going to flip it. I'm going to write as x is greater than negative 24. And the question then, if you remember back to the last video, you're going to ask yourself, is which number is smaller? Well, the negative 24 is. So negative 24 goes on the left, and 18 goes on the right. It's important that we get the order correct here. I will go ahead and make an open. I'm going to graph this x is greater than negative 24 first. So open shaded to the right. Shaded a little better than that. And then I'm going to graph x is less than or equal to 18. So it'll be a solid point. It'll be shaded to the left. Now again, we said this is a compound and. This is a compound and. So we care where they overlap. I use an open point on the negative 24 because they don't overlap in that open circle. I'll use a solid point or a closed point on the 18, and they overlap in the middle. Again, when we think of a classic and, this is what you're going to think of. Here we have another compound and. You'll notice that I do not have to split this apart. Remember, ands can look 2 ways. It can either be like the previous slide where we kind of had it all written together, or we can have the word and in the middle. All right, again, and with the word and, we're looking at where these would overlap when we finish. So you're going to go ahead and take both of these and solve them for x. So you're going to move this 5 on the left one by subtracting it. you end up with 2x is less than or equal to negative 10. I'm going to divide by 2 on both sides. I end up with x is less than or equal to negative 5. On the right-hand side, be mindful here. We're going to minus 9. This negative, I'm going to kind of write it off to the right here because I don't want to get too cramped there. It becomes negative 3x. The negative stays on that 3x there. Okay, stays right on there. Is less than negative 18. I am now going to divide by a negative number. So once again, you're dividing by a negative number on both sides. The inequality better flip. So I have my two inequalities. This is an and. Negative 5 is the smaller of the two. I'm going to graph the x is less than negative 5 first, closed and to the left. I will graph the x is greater than 6 on the second line. So this is open and shaded to the left. And they don't overlap at all, so you don't shade anywhere. This is a compound OR. So I'm going to be looking at putting them both down no matter what. Again, solve each individually. I'm going to divide by a negative 3. Inequality gets flipped because I divided by a negative. You end up with n is greater than or equal to 4. I'm going to subtract 5 here. N becomes less than or equal to negative 3. So those are my two inequalities. Now be careful. Negative 3 is the smaller. So I am now going to, just for the heck of it, I will graph the n is greater than or equal to 4, so closed and to the right. Now I'll go ahead and graph the n is less than or equal to negative 3. Again, so closed and to the left. This is a compound OR, so you're putting them both down no matter what. There's your answer. On the right-hand side, I'll subtract 6 from both sides. I'll then divide by 3. X is less than or equal to 10. Now we're going to graph these. Again, it's an OR. It's important to realize that the negative 5 is smaller than 10. So I'm going to go ahead and graph the left one first. This will be closed and to the right. X is greater than or equal to 5. I'll graph the right one. X is less than or equal to 10. They overlap everywhere, so you shade the entire one. So this would be one of, again, we did an example like this earlier, but it'd be like if we had infinite solutions solving just for one single inequality.